Hello friends, so welcome to this session on quadratic equation, and we will be trying to revise the
Hello friends, so welcome to this.
We'll be trying to revise the concepts of quadratic equations in 2 hours time. We have some slides prepared for you, and so to begin with, I'll need who all are present, so I can see there are a few students who are already there. So let's begin our class. So quadratic equation is an important chapter in your 10th board portion. So just to check whether you are able to hear my voice, you can confirm, if you're able to hear my voice in the chat. Okay, so just a confirmation if you're able to hear my. So anyone can confirm that you're able to visualize, and are you able to see the screen? Okay, good. Is the screen visible? Yeah. Okay, so let's start, and the program is something like this. We will be revising all the concepts which are there in this chapter, and then towards the end we will try and solve as many questions as possible depending upon the time which we'll be having. So let's begin. So basically we start with polynomial, right? So what is a quadratic polynomial? So a quadratic polynomial is nothing but a polynomial of degree 2 and is called a quadratic polynomial. So any polynomial with degree 2 is called a quadratic polynomial. The general form of a quadratic polynomial is ax square. So hence general form of a quadratic polynomial is ax square plus bx plus c, where a, b, c are real numbers, right? So a, b, and c all belong to the set of real numbers, and a cannot be 0. Why? If a becomes 0, then this polynomial is reduced to a linear polynomial. So hence a cannot be 0. So this is a example, or let's say this is a definition of a quadratic polynomial. Yeah. Okay. So what's next? So let us go to the next slide. We'll try to cover the topics quickly, and then we will be going to problem solving. So now the second thing is, if px equals ax square plus bx plus c and a not equal to 0 is a quadratic polynomial and alpha is a real number, then p of alpha is equal to a alpha square plus b alpha plus c is known as the value of the quadratic polynomial, right? So hence example will be, let's say px is equal to 2x square plus x plus 1, let's say, then p of 1 is called the value of the polynomial at x equals to 1. So at p equals to 1 will be nothing but 2 times 1 square plus 1 plus 1, which is nothing but 4, right? So hence this is meant by what is meant by the value of a polynomial at any given x. Okay. Next, in case during this, we will be a little fast in revising. So in case you have any doubt, you can always post either as a WhatsApp query or in the chat sessions also. Yeah. Next is a real number alpha is said to be a 0, right? A real number, again, we are dealing with real numbers. A real number alpha is said to be a 0 of the quadratic polynomial, right? So let's say if I have a quadratic polynomial px equals ax square plus bx plus c, please remember always this is the general form of the quadratic polynomial. And if alpha is the 0, if alpha is the 0, then that is if alpha is a 0 of this of px, then alpha is that value which will make px 0. So hence that means if I plug in alpha in place of x, you will get p of alpha 0. That means a times alpha square plus b alpha plus c equals 0, right? So let's take an example. If px is, let's say, a square minus 2x, or rather we will be taking it as x square So x square minus 2x plus 1. Okay. So if you see p of 1, that means if I plug in 1 in place of x, I will get 1 square minus 2 times 1 plus 1, which is 0. So hence we can say 0, or we can say 1 is the 0 of px. Okay, this is what this is meant. This is meant by what is meant by 0 of a polynomial. Okay. Next, move to the next slide. Next slide is, yeah. So next one is card number 4, which says if px is equal to ax square plus bx plus c is a quadratic polynomial, then px equals to 0. That is, so this is a definition of a quadratic equation. So equate any quadratic polynomial to 0, you will get a quadratic equation. There is nothing much to delve into it. So quadratic equation definition is, there is a polynomial which is ax square plus bx plus c. So ax square plus bx plus c, let's say if you equate it to 0, or for that matter any other number if you also equate it to, and then express in this form ax square plus bx plus c equals to 0, then it is a quadratic equation. Mind you, a cannot be 0. A cannot be 0. Why? If a becomes 0, then it is reduced to bx plus c equals 0, which is nothing but a linear equation in one variable, the linear equation. Okay, so please be mindful of this. Let's go to the next slide. Next slide, what is there in the next slide? Next slide says a real number alpha, right? A real number alpha is said to be a root. Mind the word. So if real number alpha is said to be a root of the quadratic equation ax square plus bx plus c equals to 0, if a alpha square plus b alpha plus c equals 0. This is, time and again you have done it, so no point investing more time into it. So hence, if alpha is the root, then if you deploy that alpha in the equation, you will get both sides, LHS as well as RHS, to be equal to 0, right? A real number alpha is said to be a root of the quadratic equation if and only if alpha is 0 of the polynomial. So these are, we are trying to relate two things. So let's say we studied 0 of a polynomial. 0 of a polynomial. What is the 0 of a polynomial? That particular value of the variable which makes the polynomial 0. So if 0 of a polynomial will become nothing but root of the equation. Root of the equation. Which equation? If you equate, let's say the polynomial was px, then if you equate that px to 0, then that becomes root of this polynomial, right? Root of px. So same value, let's say if alpha is 0 of polynomial px, then alpha will be the root of equation px equals to 0. Okay, so this is about root and zeros. Let's go to the next slide. Next slide is, yeah. So, okay, so this is if ax square plus bx plus c, a not equals to 0, is factorizable into a product of two linear factors, then the roots of the quadratic equation can be found out by equating each factor to 0. So this is nothing but now we are heading towards how to solve, or sorry, wait a minute. Okay, yeah. So it's nothing but how to solve a quadratic equation. How to solve a quadratic equation. So method number 1 is factorization method. Factorization method. So in your exams, there will be categorical questions where they will be saying, using factorization method, solve this quadratic equation, and we'll see problems related to that a little later. But or we can also parallelly solve questions like that. But then the question will be using factorization method, solve it. Another is something called completing the square method. Completing the square method. This is the second method through which you can solve any quadratic equation. And third is by quadratic formula, right? Which actually quadratic formula. Now quadratic formula is a direct fallout of completing the square method only. So they are linked. So quadratic formula comes from this, but then now we have a direct formula to solve any quadratic equation. Correct. Now we'll take up factorization method and completing the square method and quadratic formula one by one. So what is factorization method? Let me take to this slide now. Quadratic, let's say factorization method. So what do you do in factorization method? Factorization method. Okay, so let's say you have, and we'll use examples. Let's say one question is given, and the question is using a quadratic, let's say factorization method, solve this very simple question: x squared plus 6x plus 5 equals 0. We'll take difficult ones as well. So x squared plus 6x plus 5 equals to 0. In factorization method, which you have already learned, we try and split the middle term, right? So split the middle term such that, let's say if you have a general equation ax squared plus bx plus c equals 0, what do you need to do? You first multiply a and c, find the value, okay, and then try to break b into b1 plus b2 as sum of b1 plus b2, such that b1 b2, the product of b1 and b2, should be equal to a and c, ac, right? This is how we do the factorization method solution. Okay, now, so x square plus 6x. Now, what is a here? Value of a, let me write, is 1. Value of b is 6 and c is 5. So ac is equal to 5. Correct? Now, b is equal to 6. Now, I have to break 6 into two terms, into two parts, such that b1 plus b2 is 6. And b1, b2 must be equal to ac, which is 5. Now, a and c are integers, okay, and 5 is a prime number. So the only way you can factorize 5 is you can write 5 into 1, right? So hence, b1 becomes 5 and b2 becomes 1. If you see, it clearly satisfies this relationship. So hence, from here, we can say it can be written as x squared plus 5x plus x plus 5 equals 0. So hence, x times x plus 5, take x common, plus 1 times x plus 5 equals 0. So hence, it is x plus 5 times x plus 1 equals 0. Now, there are there are two factors whose multiplication, whose product is 0. So it is possible only when x plus 5 equals to 0 or x plus 1 equals to 0. That means if this is true, then x equals -5. And if this is true, then x equals -1. Okay, so this is the solution. So hence x equals to -5 and x equals to -1 are the solution. Okay, you also remember, guys, for quadratic equations, the maximum number of solution you can have, or maximum number of roots you can have, is 2. Either the quadratic equation will have no solution, or it will have only one solution, which we say as equal solutions, or it will have two real solutions. So hence, what do I say? The quadratic equation will have no real solution. We'll see later on what are the conditions. No real solution, or it can have two equal solutions, and third is two unique or two equal solutions. Now we are talking in terms of only real numbers. We are not going into the realm of complex numbers. So all are, so if these are valid, then these are valid for, as in the solutions are in real domain. Okay, so we will see some more problems on this. Okay, let's see what else. Let's take up some more questions on factorization method, then we will proceed. Okay, so the question is solve the following quadratic equation by factorization method, and the question is this. Question is x square plus 2 root 2x minus 6 equals 0. Again, what is a? A is 1. What is b? B is positive 2 root 2, and c is -6. Okay, now I have to, what is ac? AC is 6. Okay, and b I have to split in such a way that b1 plus b2 is equal to 2 root 2, and and b1 b2 is equal to 6, isn't it? b1, sorry, not 6, negative 6. Okay, now if you see, there is an irrational term here. 2 root 2 is an irrational number, and but b1 b2 is, which is equal to ac. Sorry, ac is negative 6 here, so negative 6, right? Or ac is, or this is equal to ac, sorry, this is equal to ac, right? Now we have to split in such a way, so we have to split 2 root 2 in such a way that the product is rational. Now, how can that be possible, that a sum of two numbers is irrational but product is rational? That can be possible only when you eliminate the irrational part from here. And that is possible only when I multiply 2 root 2 by at least root 2. But now the sum must be, the sum must be 2 root 2, but the product must be negative 6. Now, another thing to be taken care of is, if the sign of b1 plus b2 is not same as b1 b2, then what we do is we express b1 and b2 as subtraction of a larger number minus a smaller number. So hence 2 root 2, if you see, can be expressed as 3 root 2 minus root 2. And why did I do this? So if you multiply these two numbers, you will certainly get 6, negative 6 rather, and the sum also is 2 root 2. So hence the splitting of the middle term in this case will be 3 root 2x minus root 2x minus 6 equals 0. So x is common to it, so x plus 3 root 2, and then here again, if you see, this is minus root 2 common here, so this is x plus 3 root 2, x plus 3 root 2, this is equal to 0. Now if you see, this is nothing but x plus 3 root 2 into x minus root 2 equals 0. So hence, if you equate this is x plus 3 root 2 equals to 0, and x minus root 2 equals to 0. So hence, from the first one, you get x equals to negative 3 root 2, and here you will get x equals to root 2. Okay, this is how you have to solve. Let us take a little bit more. Yeah, so let us take a CBSE 2013 question. What is CBSE 2013 question? What does it say? Okay. So let us say we are trying to solve CBSE 2013 question. Okay, CBSE 2013 question. The question says, solve again by factorization method, and the equation given is 1 upon x minus 2 plus 2 upon x minus 1. 2 upon x minus 1 is equal to 6 upon x. This is CBSE 2013 sum. Question asked in CBSE 2013 examination. So 1 upon x minus 2 plus 2 upon x minus 1 equals to 6 by x. Now, clearly this is not a quadratic equation in this form, but it can be reduced to 1. How? So let us take LCM and try and reduce it to a quadratic form. So hence it is nothing but x minus 2 and x minus 1 as a common denominator. So here is 1, so 1 times x minus 1, and here is 2, so 2 times x minus 2, and this must be equal to 6 upon x on the right hand side. Now the problem is reduced only for simplification. So if you simplify, this is x minus 1 plus twice of x minus 4 divided by, if you see, this is x square minus 2x minus x plus 2, and this is equal to 6 upon x. Okay, now let us cross multiply. Cross multiplying, I will get x times x. So this is nothing but, if you simplify further, this is x plus 2x, which is 3x, and minus 1 minus 4 is minus 5. Okay, and this has to be equal to 6 times. Here, if you simplify, you will get x squared minus 3x plus 2. Correct? So if you see, simplify further, this is 3x squared minus 5x, and this equals 6x squared minus 18x plus 12. Okay, now it is again, we just need to reduce it further, and then you will get a quadratic equation. So if you simplify everything, you will get 6x squared minus 3x squared is 3x squared minus 18x, and then minus 5x go on to the other side, it becomes minus 13x, and here is plus 12, and this is equal to 0. Okay, so hence we get an equation. We get an equation 3x square minus 13x plus 12 equals to 0. Now again, what is a here? A is equal to 3, b equals to negative 13, and c equals 12. So AC is nothing but 36. Now I have to split b in such a way that b1 plus b2 is negative 13, and b1 b2 is equal to AC, which is equal to 36. Now how to do that? In such cases, we find out all the integral pair of factors of AC. So hence I'll do this work here. So let's say 36 can be expressed as 1 into 36. Okay, clearly 1 and 36 will not yield you 13. So basically negative 1 into negative 36 will have to do like that. And then 36 can also be written as 2 into 18, right? But 18 and 2 also will not give you 13 here. So 36 can also be written as 3 into 12. Okay, but this again is not going to yield minus 13. So 36 now is nothing but 4 into 9. And this is something which is interesting. Why? Because 9 plus 4 is 13. So hence we now get the splits. So hence basically it can be written as 3x square minus 9x minus 4x plus 12 equals 0. If you now see, negative 9 into negative 4 is 36, and negative 9 plus negative 4 is negative 13. So hence it is, now you have to just, the question remains to just find out the commons. So 3x is gone, so it is x minus 3, and then here 4 is common, so x minus 3 equals 0. So this is reduced to x minus 3 times 3x minus 4 equals 0. So hence either x minus 3 equals 0 or 3x minus 4 equals 0. So hence from this you will get x equals to 3, and from this you get x equals 4 upon 3. Okay, so this is a trick. For example, if you see here, b was negative and a and c were positive. In such case, rest assured that the roots will be positive. So hence b, you can take down as a trick. So let's say a was positive, a was greater than 0, b was less than 0, and c was again greater than 0. In such cases, both either both the roots will be positive or both the roots will be negative. You can take that as a trick. Now, just to check whether you have solved the equation correctly. Now, having seen this, let's go back to our this thing. So we now learned what was our factorization method. So this is done. We will see completing the square method in quadratic formula in a little while. Now, let's go back to next slide. So yeah. The roots of a quadratic equation can also be found by using the method of completing the square. So let us do the completing the square method quickly, though the proofs are not asked in the exam, but you must know because the process is important. Now let's go to completing the square method. Okay, now, so let me, yeah. So what is the completing the square method? Let's see. So completing the square method, let us say, so we are now dealing with completing the square method. So as the name suggests, we need to complete some square. What kind of a square? Here it is a binomial square we are going to complete. How? Let us say the equation was ax square plus bx plus c equals 0, where a clearly is not equal to 0. Now what we can do is divide the equation by a. So what will you get? You will get x square plus b upon ax plus c upon a equals 0, isn't it? Now if you see, guys, there is a square term and there is a term which contains x and another factor, and there's a constant, right? So what we can do is we can try and complete this square. Means what? Let's say this is half rectangle I have shown. Why? Because we have to yet to complete this square. What does it mean? It means that if I somehow get a form x plus alpha square, what is the form? If you expand it, you'll get x square plus 2 alpha x plus alpha square, isn't it? So if you see, these two terms resemble the first two terms of this expansion of a square. So can we, hence, if we somehow add alpha square, then we can complete the whole square. That is what it means. So let us see how we do it. So hence, I'm saying it is x square plus b upon ax plus c upon a equals 0. Now, if you see, I can say this is x square plus, since I need a factor of 2 here, so then what we can do is we can multiply and divide by 2. Both. So basically, we multiply and divide this term by 2. So hence, I can say this as 2 into x into, so this x and this I have added an extra 2 here, which I will take out by doing this b upon 2a. Right? If you see now, this whole term is nothing but b by ax, but I have just manipulated it to write like that. Okay. Now this gives you a sense of x square plus 2ab kind of thing, right? So where this is b, so hence I can very well write b by 2a whole square, isn't it? But then if I have added something extra to the equation, I can get back to the original equation by subtracting the same quantity, isn't it? So this I can do now. This addition and subtraction nullifies the effect. And then finally, I can add c by a, which was already there. Now, why did I do that? If you see, you can clearly see a pattern here. This is a square, right? So hence, if you see, this is nothing but x plus b upon 2a whole squared, right? X square plus 2x times b by 2a plus b by 2a whole square can be expressed as x plus b upon 2a whole square. And this is equal to, I can take all these extra terms to the right hand side, and I can say this is b square by 4a square plus c upon a, isn't it? Now I'm writing it here. So that I don't lose the continuity. Now, if you see from here, I can say x plus b upon 2a whole square is equal to b square plus, if you take the LCM and simplify it, it will be 4ac by 4a square. Okay, so that means x plus b upon 2a will be nothing but plus minus under root b square plus 4ac upon 4a square. So hence, simplifying, you can say x is equal to minus b upon 2a plus minus, this is nothing but under root b square plus 4ac upon twice of a, right? Because under root 4a square will come out as twice of a. So hence, it is nothing but minus b plus minus under root b square plus 4ac upon twice of a. Right, so this completing the square method itself leads to, let's say, solving the quadratic or finding the quadratic formula. If you see, this is nothing but the quadratic formula, where we now know that x directly I can find out by deploying all the values here in terms of a, b, and c, and you can directly find x. Oh, I see. I'm really sorry. Yeah, there is some error. This is when I take c by a, it is sorry for this error. This is not plus, this is minus. Thanks for correcting. So this is clearly minus, so hence here it is minus. I'm sorry. So all the pluses plus c will be minus c. Yeah, so that's the correction. Thanks for correction. So this is plus plus plus, everywhere it is minus 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 and minus. Yeah, so minus b plus minus. Thanks, Ruchir, for correcting. Minus b plus minus under root b square minus 4ac by twice of a. That is what is quadratic formula. So if you see, there are two roots possible. There are, if you see, there are plus and minus. There are two roots possible. One is called, let's say, alpha. So alpha is minus b plus of under root b square minus 4ac upon twice of a. And beta is minus b minus under root b square minus 4ac upon twice of a. These are the two. Okay, these are the two roots. Let's say if we have some previous year question on solving the quadratic equation by completing the square. So yes, so it is okay. So there are lots of NCERT questions, but we will pick up something which has been asked in the previous year. So that okay, so okay, never mind. So let's solve this. Okay, so the question is solve by method of completing the square. What is the question? Question is, yeah, solve by completing the square. So the question says this: 4x square plus 4x square plus 3x, 4x square plus 3x plus 5 equals 0. Again, 4x square plus 3x plus 5 equals to 0. Okay, so first step is divided by a. So hence it will be x square plus 3 upon 4x plus 5 upon 4 equals 0. Okay, so now what do I do? X square plus twice of x into 3 by 8. Why? Because I have to multiply 2 in the denominator. Okay, but since and then the b part here is 3 by 8, so hence you have to write 3 by 8 whole square. But then as you added something, you have to subtract also, so 3 by 8 whole square, and then here it is plus 5 upon 4, which is equal to 0. Okay, so hence what do I get? I get x plus 3 by 8 whole squared is equal to 3 by 8 whole squared minus 5 upon 4. Minus 5 upon 4. So let us simplify this. This is 9 upon 64, right? Minus 5 upon 4, which is nothing but 64 will be the LCM, and hence it is 9, and hence it is hence it is 9 minus 16 4s are 64, so 16 5s are 80, so here it is negative 71 by 64. Now here is the problem. The problem is that there is a square term on the LHS, so LHS is greater than 0. Why? Because squares are always either 0 or let's say positive value, but RHS is less than 0. It's a negative number, so this is not possible. So hence we say there is no real root. There is no real root of this equation. Okay, so there is no real root to this equation. Fair enough. So this is what is called completing the square method, guys. So this is ticked up. Now next is quadratic formula. So we saw quadratic formula hand in hand, and now please remember the quadratic formula is what? Minus b plus minus under root b square minus 4ac upon twice of a. Now b square minus 4ac, guys, is called discriminant. What is it called? This is called d, and d is discriminant. Okay, we will be using this thing a little later. Just keep this in mind, right? What is meant by d and how we use d for various, or let's say finding out the nature of roots. Okay, let us take up one another good problem on solving the quadratic equation using completing the square method. Okay, so that you'll get a little bit of more hands-on. Okay, now so the question is, what is the question? Question says find the roots of the equation a square x square minus 3abx 3abx plus 2b square plus 2b square is equal to 0. This is a, yeah, there are no numerals here. It is a purely, lots of variable constants. So a square x square minus 3abx plus 2b square equals to 0, and we will be solving it by completing the square method. Now again, what do? We divide the entire, here in this case the coefficient of x is a square, so let us divide the entire equation by a square. So dividing the equation by a square, you will get x squared minus 3abx upon a squared plus twice of b square upon, sorry, a squared, and this is equal to 0. I'll write it a little clearly so that avoid overwriting, so that you don't get confused yourself. And it's always a better practice to write as neatly as possible, because you yourself should not be confused. So x square minus 3abx by a square plus 2b square by a square equals to 0. So hence I can say this is nothing but, so hence x square, I have to now do what? Multiply by 2 and keep x here, so that 2x term is here, and the rest of the term is 3ab. So 1a will be cancelled. If you see, 1a will get cancelled by this. So hence I will write 3b by a, or in fact 2a, because this one 2a over here, so I'll have to add 2 or multiply denominator by 2 as well. So 3b by twice of a. Then now this becomes my b term, so hence I'll have to complete this square, so hence I can write 3b by twice of a whole square, right? So now if you do this, the square gets completed, but since you have added an extra term to the equation, you have to remove it from it as well. So 3b by 2a whole square plus 2b square by a square, and this is equal to 0. So hence, what can I say from this thing? So this is x minus 3b upon twice of a whole square. Because if you see, this is the expansion, isn't it? This is the expansion of this first three terms. These three terms here is the square term, right? And now this must be equated to, so take everything on the other side, you'll get 9b square. So 3b square is 9b square, and then minus sign becomes positive. It's 4b square, and then here it is negative 2b square by a square. I'm sorry, this is not b square in the denominator, this is a square. This is a square. Okay, so yeah, a square. I'll write it properly so that you don't get confused. You should also avoid overwriting. Yeah, 9b square by 4a square minus 2b square by a square. So simplify this. What do you get? 4a square is the LCM. So hence it is 9b square and a square and multiplied by 2. So it is 8b square. So it is b square by 4, no, b square by 4a square. Yeah. So now if you remove the square sign, you take what? Do square root on both sides. You'll get x minus 3b upon twice of a is equal to plus minus b upon 2a. Okay, so hence what do I get as solution? So x is nothing but 3b upon twice of a plus minus b upon twice of a. So which is nothing but, so x alpha is nothing but 3b plus b upon twice of a, which is 4b by twice of a, which is 2b by a. This is solution number 1. And solution number 2 beta is equal to 3b by twice of a minus b upon twice of a, which is nothing but 3b minus b upon twice of a, which is nothing but b upon a. So if you see, the equations to this, the solutions to this equation will be x equals to b by a and y equals b by a. Now please remember, whenever you have such equations in the examination paper, always put a star mark against that question, because you need to spare some time towards the end of the question paper, as we have discussed multiple times, to check the solution. So while you check the solution, you can put any of these. If let's say if you have lesser time to revise, put any of these solutions, which you think is a simpler one, and see whether while plugged into the equation you get 0 or not. That will be a good enough indication whether you have solved it correctly. Yes, if you have enough time, you can go through the entire solution once again. So use your judgment during the exam. If you have lesser time, plug in the solution and see whether you have solved it correctly or not. So, but during the rush hour, that means towards the last 10 minutes, you will not be knowing which question was to be revised once again. So hence, I told you that put a mark in the answer script somewhere, or you can write down towards the end that these questions need to be revised once again. Okay, fair enough. So let's move on to our next discussion. So here is, so we discussed this. Roots of a quadratic equation can also be found by using the method of completing the square. And next is this quadratic formula. Now, here is important things, which is anyways is discussed in the next slide. So let me go to the next slide. Now, here is where we are talking about nature of roots of a quadratic equation. Okay, so now there will be questions on nature of roots of quadratic equation. Yeah, so how do we find out? So if you see in our quadratic formula, let me just delete this. So we are now dealing with quadratic formula. As I told you previously, we will come back to the discriminant thing, and here is what I meant. So let's say your quadratic formula alpha was equal to minus b plus under root d upon twice of a, isn't it? And beta was also equal to minus b minus under root d upon twice of a, right? These are the two solution or two roots of the quadratic equation ax square plus bx plus c equals to 0. Now, the problem is, if d, what was d? D is nothing but b square minus 4 of ac, right? Now, there is a root of d. So hence, d must be greater than or equal to 0 for alpha and beta to be real. Isn't it? Why? Because there is no solution to, square root of negative value in real numbers set. So hence d must be greater than or equal to 0. If d is less than 0, then we say that there are non-real solutions, right? Non-real solution. Those lie in the realm of complex numbers, but in your CBSE 10th grade portions, we are not going to deal with them. So hence, if d is less than 0, then there will be non-real solution. And if d is equal to 0, that means d equals to 0, then both the roots are equal, isn't it? So if you see, alpha is also equal to minus b upon 2a, and beta is also equal to minus b upon 2a. So hence, in this case, we say equal, real and equal roots. Real roots are definitely real, but they are equal. They are equal. And third is d is greater than 0. In this case, you'll have two distinct values of alpha and beta, and we say that equations have real and distinct or real and different roots. Real and distinct. This is the term, distinct roots. So you will get two roots which are different from each other. So please remember these three conditions. Questions will be asked on these. The question will be, to find out some value of a, b, and c. Given that the roots are either distinct and real, equal, real and unequal, or real and equal, or not real, imaginary, right? This can be question. We'll see such questions later on. Okay. Now let's go to the next slide. Okay, so this summarized, so we kind of, these are the theory portions related to quadratic equation. Now the questions would be either of, let's discuss what type of questions could be asked. So in our experience in previous year papers also, you have seen the questions asked are either of this form. They will give you solving the equation. Okay, usually it is of 2 and 3 marks. So solving the equation will be 1, right? And now they will ask you categorically. So please be very, very careful while you are solving the equation, as in what kind of method they are asking. So if you see in the previous slide, I'll show you. So if you see here in the next slide, they are saying solve by factorization method. We just solved this question. This is actually a CBSE question. So it is categorically saying that solve by factorization method. So and be very, very careful whenever, during excitement, what happens, people think that we know how to solve quadratic equation and they miss on the instruction given on the question paper, right? So don't miss on the instruction given on the question paper. When it says factorization method, you cannot apply a quadratic formula. And when it is, when it's nothing is mentioned, then it is your choice whether you can use your factorization method, you want to complete the square, or you want to use quadratic formula. Most of the questions which will be there in the CBSE board paper, they will be, you can solve it by factorization method most of them. Okay, so hence it's always good to solve through factorization method because it is simpler also and lesser prone to calculation mistakes. But yes, it is always a good practice to come back and check it using a quadratic formula whether you have got the correct. So in the rough side, you can always do a quick check and then see whether the solution which you have arrived at is correct or not, right? See, all the theory which we discussed, you would be knowing it already. Now the problem would be when you'll be solving the questions, either you will misread the question and hence lose marks, or while solving it you will make careless mistake and then again miss marks. And then, as we were discussing, these were the types of question which will be asked, especially in the word problem. If you misinterpret the question, then you might lose marks. So hence, please be very, very careful about it. So hence, what type of questions I told you, either it will be solving the equation. So hence, be careful. What is the method which is being asked? Whether it is a factorization method. So you have to, the moment it is a factorization method, you have to use the splitting the middle term method. So you can't use the quadratic formula. Yes, you can always check it through a quadratic formula. Then they will ask you categorically completing the square method. So then you know what to do. You divide the entire equation by the coefficient of x square, complete the square, and then take under root. And do not forget to take both plus and minus of the square root of the term which you will be obtaining. So there is one mistake people generally do. Then third is a quadratic formula, where it is always a good practice to write the value of ABC by the side of the paper. So please do write what is A, what is B, what is C. In this what happens is, let's say there is a negative number and they will try to trick you with giving some negative number, and usually people forget that negative sign. So it's always good practice to write A, what is A, then B, and then C, then write the quadratic formula, and then write the full, whenever you are deploying the number, you should be careful for the signs. So hence, these are the three type of questions which could be asked. Direct questions, solving differential equations. Quadratic equations. Now, second point is questions on nature of roots. So second type of question will be nature of roots. So, on nature of roots. So what is it? So you have to deal with discriminant. Yeah. So discriminant is b square minus 4ac. So be careful. So they will be, do not write b square plus 4ac, which I did some time ago. So you must be very, very careful of the signs which you are using, and remember it properly. So hence d equals to b square minus 4ac, and then either it is greater than equal to 0 or less than 0. Basis that, they will ask you under what conditions the nature of roots would be equal, unequal, or unreal, not real, imaginary. All those things could be there. They will, for example, if I go back to the slide, let me see. I have put one question which was a 1 marker. Usually a 1 marker or a 2 marker question is then always a word problem. Never mind. So we'll come to the word problems as well. So so the 1 marker question could be that. In fact, I have shot a few videos. If you go to our YouTube channel, you can see all those questions solved there. So you can always go through the previous year questions there. Yeah. So nature of roots. Third will be of word problems, right? So there could be word problems on quadratic equations, right? So they will give you. So let us take one word problem which was asked in previous year, and let us try and solve that question. So hence, here is the question. The question says, the numerator of a fraction is 3 less than the denominator. I have solved this question also and have posted the solution online on our YouTube channel, so you can go there and see that. So the numerator of a fraction is 3. Wait a minute. I'm sorry. 3 less than. Yeah. So the numerator of a fraction is 3 less than the denominator. Okay. The numerator of a fraction is 3 less than the denominator. So I will highlight this. 3 less than denominator. So if I now know if x is the numerator of a fraction is 3 less than the denominator. That means denominator is x plus 3. Okay, this is the fraction. If 2 is added to both the numerator and the denominator, so let us add 2. So hence it is x plus 2, and the denominator becomes x plus 5. And this is the case. 2 is added to both the numerator and the denominator, then the sum of the new fraction and the original fraction is 29 by 20. So hence, what can I say? Okay, so hence it is, let me, so just 29 by 20 is the sum. So let me go to this slide and then solve it here. So let us say, so so we'll solve it here. Okay, so let us say they're saying that numerator is 3 less than the denominator, and 2 is ordered to both numerator and denominator, and the sum of the two is 29 by 20. Let us please read the question at least 2 times to make sure that you do not misread the question. The numerator of a fraction is 3 less than the denominator, so x upon x plus 3, and 2 is added to both the numerator and the denominator. Then the sum of the new fraction and the original fraction is 29 upon 20, and you have to find the original fraction. Very good. So basically now you have to find out x upon x plus 3. Clearly, this is not a quadratic equation in this form, but it can be reduced to 1. How? Let us take the LCM. So hence, if you say take the LCM, x plus 3 and x plus 5 on the denominator, and here it is x times x plus 5, and here it is x plus 2 times x plus 3, and this is equal to 29 upon 20. Guys, 29 is a very odd, it's a prime number, and the moment you see a number like 29, there's a thought in the mind that it will be difficult to multiply with 29. So be very, very cautious. So hence one thing which happens in these questions is, what is that? That is, you are prone to do careless mistakes or calculation mistakes. Please always remind yourself that there is a possibility of careless mistakes. So be very, very cautious. Okay, so let us try and solve this. So x times x is x squared plus 5x. Then here, if you know the identity, you can use, what is the identity? Let's say x plus a into x plus b. I know the identity is nothing but x square plus a plus b x plus ab, right? If you know that, then you can easily do this multiplication, or you can do a proper step-by-step multiplication. So I will say, if you don't remember, then you multiply step by step. So here it is x square plus 3x plus 2x plus 6, right? And it is always a good practice to count the number of terms also, so that you don't have, you shouldn't miss any particular term. So product of two factors, which two terms each will give you 4 terms. So see, I have got 4 terms, right? And in the denominator again, I should get 4 terms. What is it? X square plus 5x plus 3x plus 15. So 4 terms, right? And then here it is 29 upon 20. Okay, now simplify. X square plus x square is 2x square. Then 5x plus 3x plus 2x is plus 10x, isn't it? And then it is 6. And then in the denominator, it is x squared plus 8x plus 15 equals 29 upon 20. Now is the time to do cross multiplication. So hence it is 20 times 2x square plus 10x plus 6. I hope I am not making any mistake. 29 anyways will be checking. So 29x square plus 8x plus 15. Exactly, this will be the scenario when you will be writing the exam. So let us now calculate. It is nothing but 40x square. Then it is 200x. Isn't it? 20 into 2 is 40, so 200, and then it is 120, and this is 29x squared plus 8 into 29 is nothing but 8 into 30 minus 8, so this is 232, I believe. So 8 9 is 72, 7 carries 7, 16 plus 7 to 32, and there is an x, and 29 into 15 is 30 into 15, which is 415 minus 15, that is 435. So 435, right? Hence, if you simplify, 40 minus 29 is 11x squared. 200x plus or minus 232x is minus 32x, I believe. I hope I'm not. Yeah, and then 120 minus 435 is how much? It is 235. Sorry, this is 215, right? 5 and 1, 2, 3 and 2. Sorry, 315, right? No, 120 minus 435 is. So check multiple times so that no worries, because if you make one mistake and then the entire thing will go for a toss. Yeah, 315 equals to 0. Okay, so this is my equation. Let me write the equation afresh, or let me get some space to write on. Okay, so the equation is, what is the equation? Equation is 11x square minus 32x minus 315 is equal to 0. Now, either you can go for a quadratic formula, but then I say, let us try and see if I can get a, so 11 into 315. This is a negative 11 into 350. This is AC, right? Now we have to split it in such a way that I get a sum of 32, right? How do we do it? 11 is a prime number, so let's factorize 315, which is nothing but 3 into 105, or 9 into, yeah, so it is nothing but 9 into 30 5, 9 to 35, right? So hence it is nothing but minus 11 into 3 square into 7 into 5. Correct? This is my, yeah. So now I need to find out, I need to break it in such a way. Now again, if you see AC is negative, so now if AC is negative, I have to break this B in such a way that it is a sum of two numbers, but one number has to be greater than the other in this case. Okay, this is the case, right? Now let us see. So 9 and 7, 9, 5, 45 and 63. Okay, so if you see 77 and 9, 77 and 45, I think. So it is 77 and 45. Yeah, so if you see 77 minus 45, if you see 11 into 7 is 77. And 9 into 5 is 45, 7 minus 5 is 2, 7, so 32, right? So it works. So hence I can say it is 11x square minus 77x plus 45x minus 315 equals 0. Okay, so this means this is 11x x minus 7 plus 45x minus 7 equals 0. Check with 7 into 45 is 315. Yes. 7 into 5, yeah, 315, right? It's correct. So hence it is x minus 7 and 11x plus 45 equals 0. Right? This implies either x equals to 7 or x equals to negative 45 by 11. Now clearly the fraction was, the term has to be positive, right? It was said that it is a integer. Let's go back to the question once and see what was the question. So the numerator was 3 less than the denominator. If so, hence it has to be, an integer. So hence clearly I get one integer. So x equals to 7 is one solution. So hence the fraction will be 7 upon 7 plus 3, that is 7 upon 10. Now quickly check whether this is correct or not. So 7 by 10 plus add 2 to numerator and denominator must be equal to 29 by 20. Let's check whether that is correct or not. So 10 and 12, if you see 60 is the LCM. So this is 6 into 7, 42, and then this is 12 into 5, and 9 5 is the 45. So and it is 87 by 60. So divided by 3, you'll get 29 by 20. That means it is correct. It is correct. So hence the fraction is 7 upon 10. This was a previous year question paper. So these are usually the questions which are asked in quadratic equation topic. Let us take a few more and see whether we are okay. Okay, so let me solve another problem, which is yes. Okay, so let me take another CBSE problem. Now the question is, let me go to a new slide. Okay, so now the question is, find the values of k for which the given equation has real and equal roots. And this is CBSE 2015 question. Even if the pattern has changed, the nature of question will be similar. So the question is, find the value of k, find the value of k such that such that such that such that k plus 1 x squared minus 2 times k minus 1, k plus 1 x squared minus 2 times k minus 1 x plus 1 equals 0. Again, read the question carefully again and again. Don't misread the question. So find the value of k such that the equation k plus 1 x squared minus twice k minus 1 x plus 1 equals to 0. 0 has real and equal roots. Now this is another way of testing. What they will do is they will give you a quadratic equation within a quadratic equation in terms of, so you in this question also, though you have to find out the coefficients here, but actually it will lead to, let's say, use of solving a quadratic equation itself. So what is the condition for real and equal roots? That condition number 2, that means d must be equal to 0. What was d? D was b square minus 4ac. So b square minus 4ac must be equal to 0. Yeah. So what did I tell you? Write a, b, and c. So what is a? A is k plus 1, right? B is negative twice k minus 1, and c is clearly 1. C is clearly 1, right? Now let us find out the value of d. So b square. So hence write 2k minus 1, and do not hesitate to put as many braces as possible. So twice square minus 4 into a. A is k plus 1 and c is 1. So 1, and this must be equal to 0. So for real and equal roots, this must be satisfied. Now, if you see, what is it? If you square it, the negative sign has got no effect. So it is 4k minus 1 whole squared minus 4k minus 4 must be equal to 0. Isn't it? I have expanded it. And now let us expand this. What is it? 4 times k square minus 2k plus 1 a plus b plus, a plus b whole square is a square plus twice ab plus b squared. So hence you do this, minus 4k minus 4 equals 0. So if you simplify this, this is 4k square minus 8k plus 4, right? Keep checking again immediately. Immediate check also helps a lot to eliminate any careless mistakes. So you quickly go back and see 4k square minus 8k plus 4 quickly, and then minus 4k minus 4 equals 0. Now what is it? This is 4k squared, and then minus 8k minus 4k is minus 12k. Do not make mistakes in adding with signs. And then 4 and minus 4 is 0. So it's 0. Right? This makes our job a little easier, because now you don't need to go for any complex method of solving the equation. Why? Because the coefficient is 0. So hence what you can do is you can plug out what 4k is common. So hence it is k minus 3 equals 0. So hence you get either k must be equal to 0 or k must be equal to 3. Okay, so either k must be equal to 0 or k must be equal to 3. Let us check whether that is actually the case. So if you put k equals to 0 in this equation, what will you get? You'll get x square minus x square plus 2x plus 1 equals to 0, which is a identity. If you see, if you put k equals to 0, this is a check, right? If you put k equal to 0, you will get x square plus twice of x plus 1 equals 0, which is nothing but x plus 1 whole square is equal to 0. That means it has two roots, both are equal. What are the roots? X equals to 1 and 1. Both are equal. So hence, for k equals to 0, it is valid. Let us check whether it is valid for k equals to 3 also. So in case k equals to 3, then what will happen? It will be 4x square minus 4x plus 1. Indeed, it is 2x minus 1 whole square is equal to 0. So x equals to half and x equals to half are the two equal and real roots. So hence both the solution, that is k equals to 0 and k equals to 3, will satisfy the condition, and the equation will then have real and equal roots. Okay, so let us take another problem from previous year paper. So usually these will be, let's say, either at 1 marker or a 2 marker question mostly. Okay, now the question is, there's a interesting question, and though it is not a previous year question, but then it could be asked in exam. So let us say the question says, yeah, show that the equation. The question is, show that the equation x squared plus ax minus 4 equals to 0 has real and distinct roots has real and distinct roots for all real values of a, for all real values of a. Again, read the question once again, make it a habit. Show that the equation x square plus 8x minus 4, sorry, not 8x, x square plus ax minus 4 equals 0 has real and distinct roots for all real values of a. Okay, so clear. So what is the condition for real and distinct roots? You know, d must be greater than 0, right? Not even equal. It has to be greater than 0. Okay, so let us find out d. D is nothing but, for a quadratic equation, it is b square minus, sorry, 4ac, isn't it? Now what is b here? The b value is a. If you see, don't get confused. Here the b value is a. So hence I will write a square minus 4ac. So minus 4 times 1. A is 1 in this question. So this, don't get confused by this a. Yeah, this a is nothing but b in our general equation. And here the a value is 1 and c value is -4. So hence -4 is equal to a square plus 16. Correct? Now a is a real number. A is a real number, isn't it? So hence a square is always greater than equal to 0, because real number squares cannot be negative, right? So a square is always greater than equal to 0. So clearly a square plus 16 is always greater than 0. Now it cannot be said as equal to 0 because 16 is added to a non-negative number. So a square plus 16 is always greater than 0, whatever is the value of a, isn't it? So hence d is always greater than 0, and hence it is a condition for real and distinct roots. Fair enough. So this is on nature of roots. Let us now take few more different type of question. Okay. Another question. Let's take another previous year question. So the latest, or the, so let's take up CBSE 2014. Okay, now the question again is on the nature of roots. And the question is asking this. Find the value of k. So again, find the value of k. Find the value of k for which the roots are real and equal for the following equation. Okay, and what is the equation given in CBSE 2014? This question was asked, and this is px times x minus 3 plus 9 equals 0. This is which year? This is CBSE 2014. Not that, not long back. Now Again, read the question once more. The question says, find the values of k for which the roots are real and equal. Again, real and equal. For following equation. What is the equation? Px times x minus 3 plus 9 equals 0. Now, if you see, there is no direct x square term which you can see, but it is hidden, right? So, don't get confused. You can see that if you expand this, you will get a square term. So if you see, it is nothing but px squared minus thrice px, 3 times px plus 9 equals 0. Now, for real and equal, what do I know? D must be equal to 0 for real and equal roots. Isn't it? So if that is so, then what is D? D is b square minus 4ac must be equal to 0. Now what is b? B in this case is negative 3p. If you see, negative 3p is b. So b square, that means square of this, minus 4 into p into 9 must be equal to 0. So if you see, this is 9p square minus 36p equals 0. You can you need not multiply it here also, because there is a you can extract a common factor. So you can now say 9p into p minus 4, isn't it, equals 0. So if this is the case, then either p equals to 0 or p must be equal to 4. Again, there are two solutions to this. So let us check if p equals to 0. Actually, p cannot be 0. If you see, p cannot be 0. Why? In a quadratic equation, the coefficient cannot be 0. So hence, you have to write p cannot be 0. Or you can write p can't be 0, can't be 0, can't be 0, because you name it as 1 and say because 1 is a quadratic equation. But hence, let us check what if p equals to 4. So if p equals to 4, the equation becomes 4x square. Let us check. So let us check 4x square minus this. Check you don't do while solving the question in the main sheet. You can always do it in the rough. So 4x square minus 3 into p. P is 4 again into x plus 9, isn't it? So which is nothing but this is yeah. So this is 2x whole square minus yeah, so this is 2 into 2x into 3. If you see, yeah, 4x into 3 is this, plus 3 square, this is equal to 0, this is equal to 0, and hence it is 2x minus 3 whole square is equal to 0. So hence there is only one solution, and equal roots, right? What is that? 3x equals to 3 by 2. So hence p is equal to 4 is the right answer. Okay, guys, so we solved this question also on nature of roots. Let us go and solve some word problems now. Okay, there are different types of word problems. We'll take up one by one. We just saw numerator and denominator kind of a, yeah. Yes, let us take up some previous year questions. First is on digits of a, yeah. So let us take up some previous year questions. Next is now. Meanwhile, guys, if you have any question in your mind, or let's say if you are not able to solve anything, you can always post it here or through WhatsApp, and we will be able to solve it and post it here. Okay. Let us take another question. So question was asked. This question was asked in 2006. Question was asked in 2006 CBSE. What is the question? Question is a two-digit number. A two-digit number. Two-digit number is such that the product of its digit, that the product of its digits is 18. Okay, when 63 is subtracted when 63 is subtracted from the number, the digits interchange their places. The digits interchange their places. So you have to find the number. Find the number. Once again, read the question once again so that you don't make a mistake. Okay, the question says a two-digit number is such that the product of its digits is 18. When 63 is subtracted from the number, the digits interchange their places. Find the number. Now, this is interesting. Interchanging of the digits, right? So let's say two-digit number is such that the product of its digit is 18. So if one digit, you write like this. Let one of the digits be x, then the other digit will be 18 upon x. Now in such questions, you know that digits will be an integer, right? And digit, what integer? From 0 to 9. But clearly x is not 0. Why? Because if x were 0, I'm sorry guys. So if x is 0, then you will not get the product of the two digits as 18. Also, x cannot be 18. Why? So you can do these things should go in your mind parallelly. You don't need to stop and think like this, but I'm just giving you hints to how to eliminate your or how to get to answers. And it is also can help you in, let's say, checking whether you have done it correctly or not. So x clearly cannot be 18, because if you see 18 is the product of two digits 18, so 18 can be 1 into 18. 18 can be equal to 2 into 9. So here is one possibility. 18 can be also written as 3 into 6, another possibility, right? And then 6 into 3, and then 9 into 2, and then 18 into 1 again. So hence, if you see, either it will be, so either of these solutions will be there. Okay, but let's go ahead and see whether we are doing it correctly or not. So yeah, now the second is, when 63 is subtracted from the number. So what is the number, guys? Let's say x is units place. Okay, so let's say x is in units place, or one of the digits be x. Let's say you also write units place. Units place. Okay, so what is the number? So the number will be nothing but 10 into 18 upon x plus x. This is the number, right? Why? Because if you are having a two-digit number, let's say AB, then the value of the number is A into 10 plus B. All of you know this. I'm not writing, I'm explaining it again. So this is the number 10 into 18 upon x plus x. Now, what are they saying? If 63 subtracted from the number, the digit interchanges. So let us subtract some 63 from it. So 180 by x plus x minus 63. So when we do that, the digits interchange its place. So units becomes tens and tens becomes units. So it will be now 10x plus 18 by x. So this is the question. Now, once you are done with formulating an equation, your job is half done. You have to just solve the equation. So let us see, try and solve this. Okay. So once it is a better practice to check once again whether the formulation of the equation is correct or not. So if you see, this is 10x. So 10 times the digit at the tens place plus the units place digit minus 63 is equal to the reversal of digits. Okay, looks good. So let us now solve it by collating all the x terms together. So if you see, this is nothing but 180 by x. And so let's take everything on the right hand side. This means that 10x minus x is 9x. Okay, so this x will go on to the right hand side. If you are not comfortable with that, then you please write full step. Full step will be this 10x plus 18 by x, and then this becomes minus 180 by x. This becomes minus x, and plus 63 equals 0. Okay, but directly also you can write as what? So 9x, and then 9, and then 180 minus 18. So this is nothing but 162 by x, right? And then plus 63 equals 0. Isn't it? So 9x minus 162 by x plus 63 equals to 0. You can make it, it is not a quadratic form right now, but you can reduce it to 1. So it is 9x squared minus 162 plus 63x equals 0, right? So hence it is x 9x squared. Yeah, so if you see, you can actually take out 9 from everywhere, isn't it? All are multiples of 9. All the coefficients are multiple of 9. So you can say x squared, strike of 9, minus this is 18x, sorry 18, and this is 7x equals 0. Yeah, so hence it is x squared plus 7x minus 18 equals 0. This implies you can write x squared minus 9x plus 2x, sorry, the other way around. So hence this is what I was saying. Please be very, every step you just do a mental recalculation. So plus 9 and minus 2x minus 18 equals 0. This implies you can take x as common from the first two terms, so x plus 9. And this is negative 2 common from the second last two terms, x plus 9 equals 0. And hence, I am writing it here. Now it is nothing but x plus 9 times x minus 2 equals 0, x equals to negative 9, or x equals 2. Right? Clearly, x equals to negative 9 is not a solution because we are talking about digits. Digits are between 0 to 9, both inclusive. So x equals to 2 will be the right answer. So when x equals to 2, the number is 18 by 2, 92. So hence the number is 92. Right? 92. Now if you subtract 63 from here, what will you get? You will get 29. You should get 29. So if you see, 92 minus 63 is actually 29. So hence the number, the digits are interchanging its places, right? So hence our solution is correct. Okay, so this was another type of problem. Let's go to another one, another different type. Okay, so let us solve another. Yeah, now quadratic equations for solving problems on time and distance. So we'll take up one time and distance problem also. This is also very commonly asked. Okay. Yeah. So let me use this space. Yeah. So the question is this, and I'll take up a previous year paper question. Okay. So this is again 2006 paper, which is there. So there is absolutely no problem in solving a little older questions also. Why? Because the pattern of the question remains the same, or rather we can take up a recent one. So 2000, the question is a motorboat whose speed in still water is 18 kilometers per hour. Also be mindful of the units. Okay, takes 1 hour more to go 24 kilometer upstream than to return downstream to the same spot. Okay, find the speed of the stream. You have to find the speed of the stream. Okay, so once again, a motorboat whose speed in still water is 18 kmph, 18 kilometers per hour. It takes 1 hour more to go 24 kilometer upstream, that to return downstream to the same spot. Find the speed of the stream. Okay, so whatever is required, you assume that to be the variable. That is a common trend or common practice. Find the speed of the stream. So I'll say let the speed of the stream be x kilometers per hour. Write the units here itself, so that even if you miss writing units little, in the last step, then it should not make, or you should not attract any penalty. Now, a motorboat whose speed in still water is 18 kilometers per hour. Obviously, when it is going downstream, its speed will be more. Why? Because the velocity of the water will aid the velocity of the motorboat, and while it is going upstream, it will have a lesser speed, isn't it? So now it is saying 1 hour more. So what is what is constant here? The constant is the speed, the distance, right? So distance traveled upstream is equal to distance traveled downstream. So what is distance traveled? Distance, okay, 24 kilometers is given actually. Anyways, 1 hour more to go 24 kilometer upstream. Okay, so distance is 24 kilometers. So distance is equal to speed into time. We know that. In case if speed is constant, then distance is speed into time. So hence 24 kilometers is equal to speed of, let's say, while going upstream, it takes time t. Okay, so so the speed was x and it is 8, right? So hence, so what will happen? So let us write this thing separately. So hence, velocity upstream, that means when the or the speed upstream, when the steamer or the boat is going upstream, the velocity will be 18 minus x kilometers per hour, isn't it? Kilometers per hour. Why? Because the velocity will be reduced because the motor boat has to go against the speed of the stream. Okay, now, and velocity downstream is equal to 18 plus x kilometers per hour, isn't it? 18 plus x kilometers per hour. Now, so while it is going upstream, so distance is 24 into up, yeah, so time low, so hence we'll say time upstream. Okay, time upstream is equal to nothing but distance by speed, isn't it? So distance is 24 and speed for upstream is 18 minus x. Okay, time downstream is equal to 24 upon 18 plus x. Now if you see, in both the t up and t down, 24, the numerator remains same, denominator is more in the second case, so hence t down is less, which is quite obvious. So denominator is more here, denominator is less here, so hence t down, that means going downstream, the speed, time taken will be lesser. Now there is a difference between the two times. Obviously this is more, isn't it? T up will be more than t down, but there's a relationship given. What is that? It takes 1 hour more to go up. That means I can write t up is equal to t down plus 1, isn't it? So hence, what is t up? So let's now form the equation. So 24 upon 18 minus x is equal to 24 upon 18 plus x plus 1. So time, I calculated time up, I calculated time down, and then I know time up is 1 hour more to go upstream, right? So this is my, so you will get 50% of the marks here itself when you are writing the equation correctly. Now the question remains to solve this. The other half is to solve the question correctly now. So hence, let us solve this. Now, how to solve this? You have to write 24 upon 18 minus x minus 24 upon 18 plus x equals 1 after rearranging. Take LCM, so it is, and 24 is common, so you can write 24 into 18 plus x, and then here it is, and in the denominator first write the denominator, so 18 minus x times 18 plus x, denominator, and hence 24 is common, so 18 plus x minus 18 minus x, like that, right, equals 1. Now what is it? So if you see, 18 minus 18 will get cancelled, it will become 2x in the denominator, so 2x, so hence it is 24 into 2x upon 18 minus x times 18 plus x equals 1. Okay, so hence if you see the next is solve this. This is 48x is equal to 18 minus x and 18 plus x. Okay, so this is 48x is equal to 18 into 18. So I'm not multiplying, I'm just keeping it like that because, you know, we'll see if we can factorize it later on. And then, oh, sorry, it is 18 square minus x square. Plain and simple. 18x minus 18 plus x is a square minus b square. Now the final equation is x square minus, sorry, plus 48x minus 18 into 18. So I'm purposefully keeping it, I'm not multiplying because anyways you'll have to factor it. Okay, so let us see how do I split 48 to get 18 into 18. Okay, so hence what is 18 into 18? 18 into 18 is 81 into 4. So if you see, this is nothing but 18 into 18. What is it? It is nothing but 3 square into 2 into 3 square into 2, right? So 99, 81 into 4, that which is nothing but 324. Yeah, but you have to break this 18 into 18 in such a way that you get 48. So obviously, since it is a negative number, so you have to break in such a manner that it is 48 is difference of two numbers whose product is 18 into 18. Okay, so let us try and see if we can get 48 here. So if you see, it is how do we? So let's say 9 into 4. So yes, 6. So 9 into 4 is 30. Yeah, no. So how do we break it? So if you see, for 40, right? So hence I have to let's break them. So hence clearly 3. I'm doing it here. So 18 into 18 can be written as 3 into, or let's start with 2. So 2 into what is left? 9, 81 into 9 into 9, 81. 81 into 2 is 162. This will not work. Then 3 into, this is also not going to work. Why? Because it is too big a number for having a difference of 48. So hence we have to find, let's say 3 into 4 is 12, and here it is, no, we'll have to 6 into 6, and rest is 20, 54. 54 and 6 is the number. If you see how 3 into 2 is 6, so 6, if you see 6 and 54 is the other factor, right? So 6 into 4 is 6 into 54 is 324, correct? So hence this will work, and 54 minus 6 is 48. So hence I get x square plus 54x minus 6x minus 324 equals 0. So this implies x into x plus 54 minus 6 times x plus 54 equals 0, and hence, yeah, so hence if you see, this is nothing but x plus 54 and x minus 6 equals 0. So either x equals to negative 54 or x equals to 6, but speed cannot be negative, right? This cannot be negative. So hence we say speed cannot be negative, can't be negative. So hence solution is x equals to 6 kilometers per hour, right? This is the solution. This was asked in 2014 CBSE paper. Let's take up another type. Now it is nothing but on ages. Let's say there is a question on age. Okay, so this is another type you'll get. Let us solve this. This is again a CBSE 2010 question. CBSE 2010 question. Yeah. Question says a girl is twice old as her sister. A girl is twice as old as her sister. Yeah, you have to convert these into expressions, right? Mathematical expressions. 4 years hence, 4 years hence. Now in 4 years hence, the product of their ages, the product of their ages, the product of their ages will be, it's mentioned in years, will be 160. Find their present ages. Find their present ages. Present ages. So a girl is twice as old as her sister. So hence you have to be careful about, you know, years hence. So please be careful. Many of you, what you do is you augment the age of one, but you forget to add to the age of the other. Right? So this is a common mistake which we have observed. Now, so what is the question? Find their present ages. Okay, so we are saying let the ages, present ages of the sisters be x and x plus, sorry, not, so twice x, right? So x and 2x. So girl is twice as old as her sister, right? X and 2x, 4 years hence. The product of their ages will be 160. So 4 years hence. 4 years hence. The ages of sisters would be how much? Would be x plus 4 and 2x plus 4. And now the product they are saying, so x plus 4 and 2x plus 4 is equal to 160. So you have to find out what is the value of x. So let us simplify this. This is 2x squared plus 4x, 2x squared plus 4x plus 8x plus 8x plus 8x and then 16 equals 160. Let me quickly check whether it is correct or not. So what is it? 2x squared, that's correct. Then 4x, that's correct. 4 into 2, 8x, that's also correct. And 4 into 4 is 16, which is equal to 160. So this implies how much? 2x squared plus 12x plus, or sorry, minus 144 equals 0. You can eliminate 2 from here. You can eliminate 2 from here. This is the question. This is the quadratic equation. So half the marks will be given here itself if you have done it correctly. So hence eliminating 2, you'll write x squared plus 6x minus 72 equals 0. You can write dividing the equation by 2. Isn't it? Now it boils down to solve this question. So hence it is, if you see 72. So 72 is to be broken in such a way that the product is 72 and the sum is 6. So it is no brainer here. You can do it as plus or plus 12x minus 6x minus 72 is equal to 0. Why? Because 12 6 are 72. If you now do this, take common, this is x plus 12 minus 6, x plus 12 equals 0. So this is x plus 12 into x minus 6 equals 0. So hence, my dear friends, x is equal to negative 12 or x equals to 6. But clearly, this is not a feasible solution, not a feasible solution. Why? Because age cannot be negative. So x equals to 6 is the right solution. Okay, so the ages of the sisters will be ages of the, or you should write present ages of the sisters are 6, and twice of 6, 2 into 6 equals to 12 years. This is about, ages problem. Okay. Now there will be few application of the same in geometry. You can use Pythagoras theorem. There will be illustrations in that. Then in mensuration, they can also combine a problem in geometry or mensuration. So we'll take up one of that sort. So let us see what is other type of other application. So one is, again CBSE 2015 question. Now this question says the area of an isosceles triangle is 60 centimeters squared, and the length of each one of its equal sides is 13 centimeter. Okay, find its base. So let's read the question once again. The area of an isosceles triangle is 60 centimeters square, and the length of each one of its equal sides is 13. Find its base. Very good. Let's try and solve this problem. So isosceles triangle we'll have to make. Okay, so this is my isosceles triangle, let's say. So in geometry problems, please do not forget to make a diagram. Okay. Now, the area of an isosceles, right? So what is an area of an isosceles triangle? So you'll have to drop a perpendicular from here. So always draw a figure whenever you are solving a geometry problem. Okay. Okay. So this is a rough diagram where you can use it for this purpose. Now, what is it given? Right. So each of the equal sides. So this is 13 centimeter. 13. So let's say A, B, C. So it's given. What is given? Given is AB is equal to AC is equal to 13 centimeter. Okay. And area of triangle ABC is equal to 60 cm square. Okay. Now I have to find what? BC. Okay. Now construction. What did you do? Construction. Drop, or you write here AD perpendicular to BC. Okay. Now clearly in an isosceles triangle, you know that BD is equal to DC, right? You can write the reason. In an isosceles triangle, the perpendicular from the vertex vertex bisects the non-equal side. Okay, so let us say BD is equal to, right? So let us say let BD is equal to X. Okay, so to find BD. Now, if BD is equal to X, then AD is equal to nothing but under root 13 square minus X square. Isn't it? AD is 13 by, and you write the reason by Pythagoras theorem. Okay. Now, what do we now do? So I now know the h. So area of triangle. So half into 2x, half into base into height, that is AD, will be equal to 60. That is what is given. Okay, so hence half into 2x. So I can just cancel this 2 off. So x into AD. What is AD? Under root is equal to 60. Isn't it? So hence, if you and then you'll write. What will you write? You will write squaring both sides. These steps, please do not forget. Squaring both sides. Right? You'll get x square into 13 square minus x square is equal to 60. Isn't it? So hence it is nothing but 13x square minus x to the power 4 is equal to 60. Or you can write x to the power 4 minus 13x square is equal to, plus 60 is equal to 0. Right? So I hope we are doing, 13 square minus x square. Yeah, half into 2x, half into, oh, wait a minute. Yeah, half into 2x into AD, which is 13 square minus x square is 60. So hence you will get x to the power 4 minus 13x square. Oh no, wait a minute. Square, this is a mistake. This is square. So this will not be 60. This will be 3600 plus 3600 equals to 0. So please be very, very careful. Oh, this is also 13 square, right? So please be very, very careful when you are doing this. So hence it is nothing but x to the power 4 minus 169x square plus 3600 equals 0. Okay, so again, either you can go for quadratic formula thing, and also it is a biquadratic equation. So you can say let x square be y. You can solve it here itself, or you can simplify by saying let x square equals to y. So the equation is reduced to y square minus 169y plus 3600. Okay. So now if you see, if you try to split 3600, so 36 into 100 is 1, but 100 plus 36 is not 136. So we'll have to do a little bit more. So if you see, it is also this is actually 44 into 125. Yes. So 125 into 44 actually will give you 3600. Yes, that's fine. I think it is correct. I'm sorry, not 40. Oh, no. Sorry, the other way around. 144 into 25. 125 doesn't divide 3600. So it is 144 into 25. Yeah, that makes sense. So 144 into 25. Yeah, is this 30? Yeah, so this is equal to 0. So hence, what will you say? You will say y square minus 44y minus 144y minus 25. Write it properly, don't overwrite. So yeah, minus 25y plus 3600 equals 0. Okay. Yes, so hence it is y times, so I'm writing it here, y times y plus 144 Yeah, so y times y plus 144, and then y plus 144 anyways will be taken out, and here it will be simply minus 25 equals to 0. Am I right? Not. Oh, sorry. Wait a minute. There is few this thing. Yeah. So that's what the problem is. You please write it very clearly. So it will not be plus. It will be minus. Right. And here also this is minus. So hence it is y minus 144 into y minus 25 equals 0. So either y is 144 or y is 25. These are the two possible solutions. So if y is 244, guys, then what will be x? X square was equal to y, isn't it? So hence we can write that means x square is 144. So x equals 12. I am neglecting minus 12. Why? Because negative 12 cannot be dimension of a triangle. So hence x equals to 12. And from here, x square equals 25. So x will be simply 5. Again, I am ignoring the negative values. Ignoring x equals to negative 12. These will definitely be the solution to these equations, but they will not be feasible solutions. X equals to negative 5. Ignoring these, right? So x is 5 or x equals to 12 centimeter. So hence you have to find out the base. So for the lack of space, I'm writing it here. So the base BC will be twice of x, that is either 10 centimeter or 24 centimeters. Okay, this is how you will be solving these sums. So I think we have covered a lot of problems today. We also covered the theory part. So I think you guys should be good now. And as I told you, there will be typically 3 types of problems which will be asked. One is solving the equation by any of the methods. Second will be on the nature of roots. And third will be word problems, where again solving of equation will be important, as in very important ingredient of the problem. So if you are solving all the previous year questions, around 20 odd questions, uh, before you take the exam, I think you should be good. And in case you have any difficulty, any doubt, or any concept has to be revisited, please reach out to me, and if needed, we will be doing another dedicated session on the same topic. I hope these revision classes are helpful to you, so please attend these. If you are not getting time, or because of, let's say, your other mock exams going on in school, if you are not able to find time, I would recommend that whenever you get time, you please go through the YouTube channel and see it, watch it at your own pace. So we will call it a day, and I hope this session was useful to you. And we will be back again with another class tomorrow. So thanks for attending the session, guys. All the best.